going to finish up this review sheet for the final. So we're doing problem number 27. These word problems are law of sines and law of cosine problems. So let's see. 2 points A and B are on opposite sides of a building. A surveyor chooses a point C 72 yards from B and 103 yards from A, with angle ACB measuring 65 degrees. How far apart are A and B to the nearest yard? Okay. Can y'all sort of picture it? So A and B are on opposite sides of a building. So I'm going to say point A and B, and there's a building right here in the middle. A surveyor chooses a point C that's 72 yards from B and 103 yards from A, with angle ACB measuring 65 degrees. So that means angle C, when it says ACB, it's tracing along 65 degrees. How far are A and B to the nearest yard? Well, is it going to be a law of sines or a law of cosines problem? Well, with the law of sines, you should be able to easily find all three angles just by subtracting. You've got to know at least two angles to use that law of sines. Like here, we only know one angle, so it's not going to be law of sines. So we're going to be using law of cosines. And which side are we told to find? How far apart are A and B? That would be this side here. Okay, so I'm calling that lowercase c, and I'm going to use the law of cosines. And since we're solving for lowercase c, what's that pattern? C squared equals, sort of starts off like the Pythagorean theorem, right? A squared plus b squared. Then it's a minus 2, these two sides right here. Cosine, this angle will coincide with this. See? So let me go ahead and label. The 103, that's lowercase b. The 72, that's lowercase a. So plugging in, I'll do that right here. C squared. 72 squared plus 103 squared minus 2 times 72 times 103 cosine 65 degrees. Now the downside to this recording is I can't show the good virtual calculator up there. I'm just going to have to punch it in like this. Y'all having any trouble punching this sort of stuff in your calculator? I'm just going to punch it in the way it's written. I've got to make sure it's in a degree mode, and this one is. And no, it's just going to. Okay, so I'm punching in 72 squared plus 103 squared minus 2 times 72 times 103 cosine 65. Ooh, times like this, I really do sound like Charlie Brown's teacher. That's c squared, so I need to take the square root of that. So second square root, second, oh, I don't guess y'all can see me hitting the A in this, but hopefully at this stage of the game. So 97.5947 don't know how it says to round it. 98 yards. So 98 yards. Any questions there? I can try to show my calculator again, but punched in all of that and took the square root. Okay. But by doing that, I'm not showing. Oh, way out there. Oops. Any questions still on number 27? Ready to do another one. Finishing up this review sheet. Ooh, number 28 is our next one. Another one of those word problems. Let's see. I guess we're going to play the odds. We just did a law of cosine, so maybe this one's a law of sine. Well, let's look through it and see. Number 28. Are y'all ready for me? I need to focus that again. It seems sort of blurry to me. Is it blurry? Can y'all see that? Well, now it's blurry because I'm focusing. No. Are we ready to move on? 28. It's the best focusing I can do. Two tracking stations are on the equator 137 miles apart. A balloon is located on a bearing of north 34 degrees east from the western station and a bearing of north 13 degrees east from the eastern station. This gave some trouble to I had a student come by my office about this one because they kept expecting the we're thinking it was going to be northwest and northeast. This weather balloon is not between them. Like here on the one we just did, the point C is between point A and B. But on this drawing, to get it pictured, drawn right, that weather balloon is to the northeast of both of these. So you're going to have your two stations, the western station and the eastern station, and the weather balloon isn't going to be right here. Right there. If it was right there, it would be to the northwest of one of them and to the northeast of the other one. Like here, northeast, northwest. It's way over here. Why? It's to the northeast of both of these. So, sketch this. So there's the two tracking stations. They're 137 miles apart. A weather balloon is located on a bearing of north 34 degrees east from the western station. Do you remember how to draw those bearings? You're sketching your north-south line and you start measuring at due north and then move 34 degrees to the east. So 34. Okay, due north, move east 34 degrees. And then you do the same thing here. Drawing your north, south, east, west grid. Or at the very least, drawing the due north grid. And it's on a bearing of north 13 degrees east from the eastern station. So starting at due north, move 13 degrees due east. How far to the nearest mile is the balloon to the western station? Well, I'm going to put in some if you want to call it Western, Eastern balloon, I think I'm just going to do it like this. A, B, C. B standing for the balloon. The A and C are the Western station and the Eastern stations. With that, look, side B is 137 miles, how I have it set up. We don't know side A, we don't know side C. Which side are we asked for? How far to the nearest mile is the balloon to the Western station? What are we trying to find?
A to B.
Okay, we're trying to find this A to B right here, which I'll call side C. Well, we know something about the angles, but let's look just in the triangle. Like this 34 degrees is not in the triangle, is it? That's this angle here to here. How do I find this angle?
Minus 90.
Yeah, so 90 degrees minus 34 degrees. So what I'm calling angle A is going to be, what's 90 minus 34? That's going to be a 56 degrees. Now what about this angle here? Am I going to subtract from 90 again? Say no. You're going to add the 90. 90 plus 13. So angle C is 103 degrees. Angle A is 56 degrees. Can we find angle B without too much trouble? What would I do to find angle B? Just do some geometry, no trigonometry.
Divide by, add them up to minus 100.
Yeah, subtract them from 180. 56 plus 103 is 159. So angle B would be 180 degrees minus 159 degrees. What's angle B equal to? 21 degrees? What am I going to use here? Law of sines or law of cosines? Sines, okay? If you know two of those angles, well, if you know 2, do you know 3? Yeah, you can subtract from 180 to get the third one. So if you know all 3 of those angles, law of sines is the way to go. So I'm going to set it up. The thing I'm looking for is side, lowercase c, side C. So C over sine C, that's the 103 degrees, equals, now what am I going to do? B over sine B or A over sine A? Which ones do I know? Both of them. Yeah, B. I know side B. Can y'all tell the difference when I say side versus sine? It's lowercase b over sine capital B. Okay. So you can cross multiply and divide. Or if you just say, okay, I'm going to multiply both sides by sine 103. That will get the lowercase c by itself. So here's what I'm going to have to punch into my calculator. 137 sine 103 degrees all over sine 21 degrees. Watch the parentheses. Make sure you're closing them correctly when you punch those in. And you should have it in degree mode, so you don't need to be, remember how you can find the little degree mark under angle? You don't need to be doing that. Okay. Just let me see on this one if I can figure out. Oh, hey, some of it's showing there. Oh, what if I move over? No. Hey, what if I turn it at an angle? But if I do that, I can't see. You know what? Sometimes it works best like. Oh well. Well, there's a downside to doing it this way rather than just. Oh well. Can y'all punch that in? 130. Let me clear it. Pretend you can see what I'm doing. 137 sine 103, close parentheses, divided by sine 21. I said 103 degrees, but I'm not really showing the degree mark. Ooh, I thought I cleared out all of that. And I guess I did. That bottom stuff, 137 sine 103, close parentheses, divided by sine 21, 372.49. And how are we told to round this? To the nearest mile, so 372. Ooh. Put this way on and see. Ooh. Like that. Any questions? Any trouble punching it in? I'll be glad to help you with it if you're. Make sure you have it in degree mode. Surely the video showed this much better. The glare comes more from that thing than from. One day, just worked really good if I just positioned it right here for my business map class. 137 sine 103 close parentheses divided by sine 21 close parentheses. Okay. Any questions there? Ready to do another one? Hey, I think we're up to the last long one. Okay? Number 26. It's just find the missing parts. It doesn't really give anything away. There's a lot of sines or law of cosines, but you got to know which one are you going to start or how are you going to go about it. Law of sines or law of cosines. Just by looking at it, you should be able to choose. Is it law of sines or law of cosines? Law of cosines. You don't know anything about the angles. Okay? In order to use that law of sines, you really need to know those, two of the angles at least. And if you know two of them, then you know three of them. So I'm just going to draw a triangle and call it ABC. Side A is 6.1. Side B is 13.6. And side C, 16.0. And we're using the law of cosines, and you're going to have to find those angles. Okay? Law of cosines. To find capital A, it goes like this. Cosine A equals. It's the other two sides. That's what you start off with. So it's B squared plus C squared, then minus this side right here over 2BC. Okay? B squared plus C squared minus A squared all over 2BC. So we write cosine A equals B squared is 13.6 squared plus C squared minus A squared all over 2 times B times C when you're punching in fractions, if there's more than one number on the top, it's best to close it in parentheses. If there's more than one number on the bottom, close it in parentheses. So, that record button is in the way. Okay, so I'm going to clear that. I'm going parentheses, 13.6 squared plus 16 squared minus 6.1 squared, close the parentheses, divided by parentheses, okay, 2 times 13.6 times 16, close parentheses. So I'm going to write down these numbers just for explanation purposes. It's 0.92773437.5. That's not the answer. That's the value of cosine A. We need to solve for A. So what cancels out a cosine? Inverse cosine. Did y'all hear that? Oh, I'm so impressed. And wow, did that sound condescending? I don't mean that to be. This is the truth, though. I'm so glad if someone had said, divide by COS. I would have been really scared. Okay, so stick inverse cosine on each side. And that gets the A by itself. So I'm now about to go second cosine. And I'm not going to retype all of that. I'll say second A and S, enter. And there it is, 21.915 ... degrees. Oh wait, we're not finished yet. We still have another one to do, don't we? Or not? Let's see. I think we're finished. How do I know I'm finished? You see, this is the only one. 21.92. A is 21.92. Okay. There. Any questions there? Just in case, since we have time, if you had wanted to find B, I want to make sure y'all see the pattern for this. If you had done B, if you'd written out cosine B equals, what would it have been? It would have been the other two sides, the A square plus C square, then minus the B square over 2, and what is it? It's these two here, AC. Okay? So, any questions there? So we're choosing angle B. I mean, no, answer A. What's the answer on that one? Yes, Emily?
When I do that, I keep getting 56.32.
Okay, let me go through it. Okay, good. Oh, that's what you got also?
And
a 56.32 rather than 34. Well, I think if we called Pearson and asked them, they would say, well, you're supposed to be choosing the best, the best answer. There's no proof that the instructions actually say choose the right answer. It's just that if you read the instructions, I remember once calling saying, hey, I have a solution to a problem there where you're off a little. And they were like, oh, and I don't have that instructions there. Where it's, that's trigonometry stuff. Anyway, okay, let's see. So it's 13.6. No. 6.1 squared plus 16 squared minus 13.6 squared all over 2 times 6.1 times 16. There might be a little bit of round off on these, okay? And if both of y'all are getting it, then I'm suspecting that's what's happening. Ooh. Bring this up a little. Oops. Hey, it just went off, did it? Okay, so I'm punching in 6.1 squared plus 16 squared minus 13.6 squared. You know what? I didn't put the parentheses around. Okay. It's not too late because I can just say enter now, so it calculated the top. Then divided by, but I better put the parentheses around the bottom here. 2 times 6.1 times 16. So it's all of that. Second cosine second. I'm probably going to be getting the same thing you got. No, I'm getting 56.32. Oh, wait, that's what you got, right? Okay, there's some sort of round off error going on.
Like if you did B first instead of C or A, you'd be like, well, none of those are the right answer.
Oh,
I know it says what you said in the beginning.
Yeah.
If I was being really literal, I would have to put D.
Oh, wow. Well,
But since you did A,
uh-huh.
that's the only one with that answer, then I would circle A.
Oh, well, I guess we haven't, I don't want to word this. The programs that they're using to calculate, more than likely, I know that from my business math class, that when there's a negative exponent, their calculations are a little off. I'm suspecting it's this inverse cosine calculation right there. If we had more digits after this 262, or maybe fewer, then you'd be more likely to get the 56.34. There's some sort of, either our calculator's rounding it off too much, or their calculator is. Okay? So, oh wow. I never noticed that. Okay? But 2 100ths of a degree off is pretty close. Okay? I'm be curious, okay, with C. Well, I guess with C, what would you do? You'd subtract from 180, so you're going to be off on that too. Okay? And I'd never noticed that. But it's more probably the numbers that came out here this time versus any set rule. Okay? So we were a little off on our rounding, okay, from what they have there. Let me give you this hint. The no solution, the no triangle is not the answer, okay? I sort of wish I hadn't put that one there as the answer. I mean, have y'all ever had multiple choice math tests where every question has a none of the above? Those are the hard ones, okay, when there's that option, none of the above. Because if you mess up, oh wow. Well, if you don't get it, I remember once years ago taking a multiple choice math test when I was in public high school or something. And every one of them is none of the above. You know everyone failed that test, okay? that teacher was deliberately being mean to all of us. But, okay. Well, we're leaving those and finishing up with these vector stuff, something nice and light. So, we ready to move on? Our students over taking finals at the distance testing center. And in case there's some sort of problem, I've got to have my phone in case they need to contact me. That's why I keep looking at it. Okay. So here we are, just little vector operations and some dot products. We end this on a light note. A is 3i, B is I plus j. Find 5a plus 5a plus b. That's 5. Replace the a with 3i. Oh wait. Sorry about that. Okay, so A is 3i, B is I plus j. Find 5a plus b. So we have a 15i plus a 1i plus a j. Is that going to be 16i plus j? I plus j. Number 30 is using that component notation, stuff that looks like the ordered pairs instead of the ij notation. So we have negative 5u, negative 5u plus 3 times v, so that's going to be a negative 30, comma, positive 10. Is it facing? Yeah. So one teacher using this in another room, and she's sitting here facing that way. Now it's like, oh wow, I would feel really awkward with my back just to y'all, sitting there with my back to you the whole time. I have to be turning around, and there are times when I can't see, or I don't notice that something's not showing up there. And I think that's better than having my back to y'all, okay? I guess what's the difference when I'm using the whiteboard up here and just writing my backs to y'all? But sitting down with my back to y'all, being sort of awkward. So negative 5 times 6, negative 2. That's a negative 30, comma 10, plus 6, 6. So what's this going to be? What numbers do I add together? Well, you add the I components and you add the j components. Is that going to be a negative 24, comma 16? Okay. Any questions there? (32) and 33. Oh wow! Let me write it bigger. It's negative 10, comma 8. Since this find the dot product, I'm going to go ahead and write it with a dot in the middle rather than the comma. 4, comma 13. You multiply these I components. Let's see. Negative 10 times 4 is a negative 40. Plus, multiply the j components. Is that an 80 plus 24? Is that a 104? So negative 40 plus 104, is that going to be a positive, 64? I was about to write 54. No, 64, okay. Is that showing? And then the same thing on 32. I prefer the component notation like that without having to write that I and j. Same thing on 33, I mean. I'm going to write it like this. 1, comma 2 dot 8 comma negative 1. So what do we have? 1 times 8 plus 2 times negative 1 is a negative 2. So is that going to be a 6? Hey, I didn't circle up here. Or write in a blank. C and B. Okay. Any questions there? Final exam is in 2 parts. First part is the no calculator part. That's problems 1 through 21 on this review. 22 through 33 are the calculator problems. So good luck on your final exam.